Probably everybody has logged in. Great, great. So today's session is very, very important. It is like saying that we are learning SQL in our databases classes. Okay. So similarly, we are learning aggregations today in MongoDB classes. And there is another very important concept which we are going to talk about is MapReduce. So even if you don't get it in first go, do not worry. uh, Ask again and again, and I'll explain again. Okay. So today we are going to talk about aggregations and MapReduce. Okay. And so far we have talked about various things like why NoSQL and what are the CRUD operations and how do you create, retrieve, update, and delete. Today, we are going to delve in detail about the R of CRUD, meaning retrieval in detail. Okay. So as and when documents add up, we need to retrieve them, put more and more conditions, and do a lot of churning and analytics on top of the documents. Okay. And to do so, aggregations have been recently introduced in recent versions, and because that was the need of the time, because the function called find and with or and or all kind of operations was not sufficing the need. So MongoDB team came up with aggregations. Okay. So aggregations are basically two form. I mean, you can say four kind of aggregations. First is aggregation pipeline. So first is pipeline, second is MapReduce, third is single purpose aggregations, and fourth topic which we are going to discuss in aggregations is the mechanics of aggregation. Okay, this is what we are going to discuss today. So let's start with the data processing pipeline. Okay. So the way we have a find function on a collection, db.orders.collection. Similarly, there is a function called aggregate. Okay. Aggregate comes up in with two parameters. First is match and second is a group. Okay. And you see this array. So basically in aggregate, you pass an array of these two things. Okay. You can keep on adding more and more phases. Okay, so this aggregate function takes an array of various kinds of phases. Okay, so what is a phase? Phase is like a SQL command, like matching, grouping, and all those things, and you pipeline those. What does it mean by pipelining? So any output of match this line, so what does it say? Let's have a look at one by one. So what we are trying to say in this line, we are saying find all the orders as here, find all the orders which are matching the status called A. Okay? And once that is matched, whatever is the output of the filtering, matching is basically filtering something based on certain conditions. Whatever is the output of that one, pass it to the next phase, and so on. So here there can be hundreds of phases in pipeline. Okay, whatever is the output of the first one goes to the second one, and so on. Okay, now let's see in detail further. So these were your orders. Orders was a collection, and and in this collection there were four documents. Okay, first document was customer ID. Customer ID A123, amount is 500, status is A. Similarly, for the second one, the amount is 250. Third one, the ID, customer ID is different, which is B212, and this amount and status is A. So if we put status colon A, only these three records are going to match. So these three records have matched by virtue of the first phase. So whatever was the output of the first phase has been fed to the group. Okay, and group is exactly like the SQL group where we say that, hey, find all the values for this column and aggregate them. Okay, find all the distinct values on this column, and for each of the distinct value aggregate the other columns. Okay, what is, so here what we are saying, take customer ID as a column. Okay, for each value of customer ID aggregate the column called sum and the aggregate column called amount, and the aggregation is to sum. Okay, so basically for each customer ID, what this command will do, that is compute the total amount. Okay, it will sum up all the amounts, give it a name called total. All right, so this is a very cursory look at aggregation pipeline. So basically an aggregation pipeline is a pipeline like a Unix pipeline where each phase, the output of the each phase is fed to the next one in the pipeline. All right, and there are various kinds of such operators like match, group, and other operators which make up the phase. Okay, each one has its own set of parameters. Everything is in JSON format. Okay, so this is a very quicker look, and let's have a uh, this is what aggregation function, or you can also say an aggregation operator. And there are various aggregation functions like project, okay, match, limit, skip, group, sort, and so on. So we will go one by one. Okay, this will be our sample data for aggregation today. So what we will do today is we will talk about all kinds of, so this is clear, right? So there are these phases. This is an array of phases. This is an array. You see the square bracket? It is basically an array object, array of phase object. From here, this curly bracket till this curly bracket is the definition of a phase. Okay, if you remove group, right, if you remove group here, what will happen is the result will be the on screen, this is what is going to get printed. Okay, yes, so this will be equivalent to find. Perfect, if you remove group. All right, and similarly after you have finished the group, you can again put a match, and you can keep on combining all of these things together. And yes, ordering is very important in in basically aggregation. If you put group first and match later, then you will have a error, right? Because here, as a result of group, you will get only two columns. One is ID, other is total. Okay, and hence there will be no status ID equals A. Hence there will be empty results. So grouping order of the phases is very important. Okay, because they are first it is going to match this one. Whatever is the output through this pipe, you can think of it as a big pipe which does some transformation inside it, and by virtue of that transformation you get some other result, and so on. So in case you change the order of transformations, you will get very different results. All right, now let's go one by one. Now what I'll do is we will take up this data. Okay, we'll take up this data set and we'll run with it for some more, some examples. We'll run through some examples here. So this basically this is the database table of the marks of a class. Okay, this is the ID and ID of a person. He belongs to class ninth, and section A, his marks were 10. Then second student, class ninth, section B, and marks, and so on. All right. So, and same thing has been represented over here. Okay. So these are the documents. Okay, these are the documents added to the student. So we'll take this, run it on the console. All right. So, okay. Is it visible to you guys now? Is it clearly visible? My screen? Great. Now, I'm going to do student at MongoDB 1.newbigdata.com. All right. This is right? Okay. And on the command prompt, if you control R and type a word, it will search in the history and you can quickly find it. So all I did was control R, and after control R, I just typed Mongo and it gave me this. All right. Now I'll do a use asgiri. That is my, I'll create a database so that I don't interfere with anybody. Similarly, you guys should also create your own database. Now I copy pasted all of this insert commands into here. Okay. So you can see clearly that we have added those 5 rows into this collection. Okay. It has 5 fields: ID, class, section, and marks. All right. Now let's move on. So this is going to be our sample data set for some of the aggregation. So let's take a look. How does it matter to MongoDB, or how do we basically, we are given this, all right? We are given this kind of class and we want to find out percentages of people. If we know that marks are out of 80, all right? So how do we do this? All we have to do is divide this number by 80 and multiply by 100, right? So yeah, we have to multiply. It's very simple, and we have to just ignore both the columns. We have to just display ID and percentages. All right. So for this, it's like a simple select query without any where clause. Okay. So we say select ID, comma, percentage as uh, whatever field multiplied by this and that. In the similar manner, we have project. Project's job is exactly selecting the fields. Okay. Project says that show me ID column 1. Okay. Show me ID. And then I say that, and first field is my ID. And when I say ID colon 1, it means that display it. If I say ID colon 0, then it won't display that particular field. Then I say percent colon my actual value, new value. So if it is an object starting with curly brackets, then MongoDB will consider it as a computation step. Okay, it will try to compute whatever is there inside it. All right. So percentage is the new column which we are trying to create, and we are using an operator called multiply. Okay, using operator called multiply, we give all the values in an array and say multiply, and we get this result. All right. So all we have done is we have said first column is our ID, second column is percentage, and how to compute percentage is by multiplying all these values. Okay. When I say all these values and one of the variable is having dollar in the name, that means it has to back reference the column. Okay. So it is like referencing a variable. So we are referencing a column name and then multiplying it. Okay. How can we show class along with the ID? Can somebody suggest quickly? What does your instinct say? Or what does the intuition say? Perfect, perfect, perfect. Great. Okay, so that is how we'll do that. So let me just show you so that you trust me and that I'm not lying. Let me go here. Okay, so what is wrong with this? We have, okay, the single quote is very bad, and yeah, that's it. Why is single this not listening to me? Okay, percentage multiply this. Let me also fix this single quote. I say aggregate, and then that's it. Yeah. Okay, one double quote is extra. Don't worry. Okay. So we have closed the percentage. We have just a second. Okay, let's see what happens. Oh, I think it's the tab. I think it is the tab. So I'll just replace tab with couple of spaces. Okay. Okay. Oh, okay. Good. Hmm. Basically, it was a formatting issue. Okay, let me, even if we don't specify ID1, then it won't, it will display. Yes, you are right, Wahid. Thank you. Yes, you are right, Wahid. I think we don't have to specify manual, then all columns will be shown. Okay, okay. So, so here, okay. So as you can see that this one, good. And let's talk about what people are just saying that let's say if I don't put ID, then also it should display it, right? Which is very, very right. And if we don't want to display it, then yes, you have to go for underscore ID dot. Okay. And in case, yeah, let me just cater to that one also. In case we just say empty curly brackets, then, okay, I forgot to close it. Let's say that we have got a great idea, and what we do is we just take this, just take this, and also note that, okay, so here it says that projection requires at least one output field. All right, if you don't specify any field, then it will be a problem. And the other thing you note is that in case you are using a single aggregation function, then you don't need to put square brackets like this. Okay, you don't need to put those. Okay, but even if you put it, it wouldn't make much of a difference. Okay, so let's say you have got this, and we just go ahead and Okay, and put an array. Then also it is the same thing. All right. So if you have a single element, you don't need to put a square bracket. It is optional. If you have multiple phases, then you need to put. So aggregation is this project aggregation is clear to you. Project function. Wait. If we want to display all the columns, we have to mention them all. Yes. And also, let's say that so the problem with the statement is that if you have to display all the columns except one, then it's easy. Okay, right. In case of project, you will have to mention at least one of the fields, and those all fields need to be specified one by one. Yeah, that is a problem with this. So select star is not there. Yeah, select star is not there. In array, can we mention dollar match of filter? In array, can we mention dollar match of filter? Yes, right? So moving on. So this is clear, right? Pretty straightforward. All you did was just a project. Now, second one. Second one. In this, what we are trying to do is take a table and transform into another one. So we want to say that show only students of section A. So basically, it's a match criteria. We just have to filter it by A. This is pretty straightforward, right? So all we do is again the double quote keeps on bothering me very much. Good. Now I think it will not bother. Good. So basically all we did was said db.students dot aggregate match, and then we say section is A, and this is what we got. All right. Yeah, it is, I think, case sensitive. Yeah. So basically it is case sensitive, and to have a non-case sensitive, you can specify some options. Here, okay. Now, next is how to show only two records, like limit. So which is pretty straightforward. We'll just say we want to show only three records. Okay. And to do that, all you do is put limit is 3, db students aggregate, and then say limit is 3. Okay. So we got the first one. That's it. Perfect. So we got the first three record. Top three, yeah. From the about top. The way they have been ordered, okay, is you will get it from that one. Okay. Now we want to see the last n records, or we want to skip two records. Yeah, it is ordered by not on column ID, basically the way they have been added. Okay. Also, in case the basically here it's fine. We are saying order equals 3. But in case there is a matching criteria in the previous phase, okay, and we have provided an order by, then that order will be taken care of, will be honored. Either we are looking at the index, whether whatever index is giving us, basically if there is an index on our column in a reverse manner and we are matching on that index on that column, then you will get all the values in the reverse order. Okay, and then you do a limit on those things. Okay, similarly, if you have put an order by, then also that default order will be dishonored. Okay, so by default, if you do not interfere or do not order reorder anything, then all the elements will be in the order the way they had been added. Okay, okay, so limit 2, limit 3, this is our skip. So you got the last three one. All right, this is pretty straightforward. And now group by is little bigger construct. So you can see here, in group by we define an id column. Okay, id column can be a single column or can be a composite column. Okay, you can group by on multiple values as well. Okay, now in this we are just a second. Okay, we are recording. Good. In this, we are basically grouping it by a class. Now here what we want to say is that what is the total of each class? Class ninth, class 10th, class 2nd, and class 2. Okay, so what we do is we define an ID called dollar class. Okay, basically we are saying back referencing the class field here and saying that for the new document that is created, whenever we do any aggregation, we are basically creating the new document. Okay, in memory document, not really persisted one, in memory document. And then we are defining a field called total. Okay, here this one is an ID, this one is an ID. Okay, and there is a field called total, and in this total field we are saying sum all the values of column called marks. Okay, now that's what is going to get summed up over here. All right, this is what is going to get summed up. Can you show group by class and section, please? This is what we are actually showing. So do you want me to run it? Okay, so here we have db.students dot find. If you see, sorry. All right. Now we want to say is that db.students dot aggregate aggregate, and then we say on what column do we want to aggregate. We want to aggregate it on say class. Okay, and we are defining a new field called total, whose value is going to get computed by the virtue of by the virtue of uh, marks. Okay, that's it. Okay, here I forgot to put a group by clause. Okay, okay. So this is how it is done. Wait, I got so many questions this time. Okay. Section also on two columns. Right, right. Wait. Rizwan, you need to just little bit wait. Why are we assigning dollar class to ID? Excellent question, and we can do it directly also, right? Also, right, using group in project. Mm, I did not get why. So basically, whenever you have to back reference a field, so ID could have been a value, right? Or it could be a reference to some variable. Okay. Or whenever you have to refer a column anywhere, then you have to put dollar before it and inside single quotes. ID is not column of the table. It's like it's key which columns to take for group by. Right, right. It's a keyword. No, actually ID basically what we are telling here you see. Okay, now it will make sense to you. Okay, so basically we are saying create a new document out of this table for which ID is this, and whatever values are there, we are defining their new columns. Okay, so we are defining a column called total and whose value is this and so on. Okay, it is like that. Make sense? Okay, now let us take uh okay, I think I had a So let me just have a look at more than one column, right? That's what I have been example looking for. So I want to, which one should I? So 9A is not there twice, so it will not make much of a sense. 10A, 9A, and then actually I need to look at something which has some aggregation. So if I say do this like class and section, it will not make much of a sense because it will be same thing because there are no values to aggregate. But anyway, just for the sake of fun example, let me just insert students insert. Okay, so we have got find, all right, db dot students dot insert, and I'm inserting one more value. All right, so let's just put its id as 6 and marks as 50. Okay, marks as 50. Now if we see db dot students dot find, let's see what is there. Good. So now if we group by 9, I mean section and class and the section, okay, and then we sum up marks, then these two should sum up while rest of the things will remain as is. Okay, db students dot aggregate, okay, and I say group, and then now I define a column called id. There will be something in the id, and then there will be something called total. Okay, and there will be something in the total. All right, now let me just complete what will be my id. Okay, so first one is my class colon 1, and I forgot that. Okay, okay, and second one is going to be my section. Okay, and I say colon 1, Okay. Or we could say, so basically we are forming a composite object, and composite object can be of this form, okay, or can be of this form. So I did make a mistake somewhere. Alright, and then I say ID is from here to here. Alright, and then I say, so my ID is this one, ID finished. Now we are talking about total. This is my total, and now the group finished, and then aggregation pipeline finish, and that's it. Total is my sum of marks. Alright, now you can see that for 9 here, 9 and A, okay, you can see for 9 and A the total value is summed up 50 plus 10, 50 plus 10. Alright, and rest of the things are there. Is it clear to you guys? No? So basically I created an ID which is a composition of class and section, and on which basis it has started grouping the elements. And here, since 9A is existing for 2 rows, that is why it has summed up and made it 60. Okay? Move on. Sanjeev? Okay, okay. So this is how you make a composite group by. Okay? This is how you make a composite group by. Now, we talked about group by, basically group projection. We keep on calling it group by all the time. And this is our pretty simple one called sort. Sort is very simple. We say that sort by this column in ascending and this column in descending. Class 1 means ascending and section -1 is descending. Okay, so this way you can see that when we say this we get, okay, so it has ordered, and similarly we can simply remove this, and then everything will be only ordered in ascending. Based on the data type, the ordering will be there. Okay, make sense? So here we have said order by class positive, which means this column is going to be in increasing order, while section is -1, this is going to be in decreasing order for same values. Okay, for like for these two values where value is same, class is same, in those cases it is reverse order for the section. Okay, so it's exactly like order by A comma B comma C, and then you say ASC or DES in case of SQL. Now there is a function called out. Okay, out, it saves the results to another collection. Okay, to another collection. Now whatever we did just now here, let's say we want to save it somewhere. Okay, So what we can do is we can pipeline the output. We can pipeline the output of the previous one and say it's put its name. Say my new collection is ordered students. All right, and this will be saved. And also note that putting array operator here around all of this argument is absolutely optional. Okay, now these are two different arguments of the function, and earlier if you put a square bracket, that was basically an array we are passing. Both mean exactly same thing, whether variable argument or argument as an array. It means both means the same thing. Now let's have a look at it. db students dot find not students, ordered 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 students dot find. So whatever order we generated, we have saved it somewhere. Yeah. So it's not like a view, it's a completely fresh table. It's like saying insert into XYZ table, select from somewhere. Can we perform out function for find? Yes. So exactly the same way, whatever we are doing, we can combine all of these things together and then save it at the end of it. Also note that this out function, yes, it is like a temporary table in SQL. Okay, but it's not like a temporary table because temporary tables get washed away. This one is more like a proper table where we say insert into XYZ table and the table gets created automatically. Okay, so also note that out will come as the last element. Out will come as the last element in the in the pipeline. Does it display whole result or display in batches? So when we say db.x dot something, it displays 20 results at a single time. Okay, it displays 20 results at a single time. Okay, yes. No, actually, that cursor is being given to you via MongoDB. Mongo as command line. It is the cursor is being created by the command line. Okay. So for all the tables, it is true. Okay. Now coming back to your question, it is when we save something into a table, basically we have created a fresh collection. It's actually a collection. It is neither a cursor nor a view. It's a proper collection. Okay, it's a complete duplication of the data. Whatever you do with it, it will stay with it. Okay, so whatever it's like saying insert into, as simple as that. Okay, whatever result we have computed so far, save it somewhere. All right. Also note that out will be the generally the last element of a pipeline. Perfect. This is what it is. Select star into ABC from my table. How to create an in-memory subset that can be referred further and should be unique per session. How to create a in-memory subset that can be referred further and should be unique per session. Mm, that you can't do much. Okay, that you can't do. Okay. What you can do is you can create a name of the collection based on the process, and then basically you can have that one only visible here, and then drop it at the end of the session. Okay, and TTL indexes is what you use such kind of things for. Okay, great, great. All right, now we have this. Now this is something new which you have not seen so far. Like, it is called dollar $unwind. Okay, whenever we have multiple values in a field and we want to flatten it and make not flatten it, we want to make multiple column, multiple rows out of it. In those cases, we use unwind. Let's take a case. Here, there is this document which has called field called a string. This is my name, this is my message, and this message has got tag called bio, name, and message. Now I want to convert this, ungroup it. It is sort of saying ungroup it. Okay, and similarly here in the group by, you see this group by elements here. Where is the group by? Here you can see some. Similarly, you can have add to set. You remember add to set we did earlier? Add to set, and therefore that will keep on adding these values into a set, making an array. Similarly, it's like ungroup it. Take an array, ungroup it, and this is what it does. So it created an ID like this. It created fresh ID, you see? It created a fresh ID of each document, and and it created first document with bio tag, and second with name, third with message. Okay, so if we group again these all documents, if we group this collection again on M and then add this to set, then we will get back the old one. Okay, so basically it is just the opposite of group by. Make sense? No? Yes? Yes, all of these keep on creating in-memory collections which can be used by the rest of the pipeline. Okay, let me explain again. So unwind is mostly like a reverse of what group did for you. Group took a column, all the values for the same column it grouped together. All right, and this does is it ungroups it. Okay, it ungroups the values of an array and makes separate documents. So Kishore, let's have a look here. We had a message called this one. We had tags, and when we said unwind by tags, we said unwind by tags, which means that keep create fresh document for each value in an array. So bio goes here, tag goes here, and another bio, name, and message. There are three different documents created with rest of the values copied all over. Okay, make sense? No, Kishore? Great. Collection or documents, Anuj's question. Hope you got your answer, Anuj. So this creates various documents inside this. Okay, let's just show this. Now we have this. If you see what does T contains, T contains something like this. T has ID, T has message, and T has name. Okay, like this, and that's it. So when we say unwind, all it does is, see, now earlier there were single document, now there are multiple documents created. Okay, The only weird thing I'm finding over here is the ID of these all documents is same. Okay. Okay, this I did not know earlier. Okay, so ID for these documents seems same. Okay, okay. So in case we regroup it by ID, we will again get what we were looking for. All right. Okay. Now, so Wajid is asking, can we run this again? So that T will remain as is. Okay. T will remain as is. It will not change T. Instead, it would create a fresh collection. Okay. So how to get this unwind docs again? You will have to save it somewhere. You can just do, save it somewhere. That's it. So how do you, okay, what is the name of this collection? So right now this is all in-memory collection. We are not saving it somewhere. Okay. Now let's try to save it. Let's try to save it. So since all of these have the same key, you cannot save it right away. You will have to change it. Okay. And this is actually awkward. This is actually awkward for me. Never mind. So basically you cannot save unwinded documents just like that. Okay. So, okay. Either something is wrong or let me just try running it. And okay. 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 So basically we might have to reproject it combining ID and tags, and only then we will be able to save it. Okay. Can we specify columns while creating out? Not yet. No. For that you can do a project and then do an out. Okay. So you can pipeline a project before the out while selecting the columns. Okay. So in this case, what you can do is basically take this and and we can do unwind tags, right? And then I said project, and then I say underscore ID and 0. All right. So let me try to show you. Okay. So let's say I'm saying 0 and m equals 1 tags colon 1. Now I can save it, and now it will create a documents for me. Yeah. So if I say db.x.find, I should find this, and they all have the different one. Yeah. So yeah, I got the idea from your discussion only, Wahid. Okay. So basically we did was hit the first one column, and that's all. Okay. Basically it creates the same document, which is I should just say, okay, it should have the same document. not 2, I'll just put it 3. All right. Now moving on. So unwind is clear to everyone. Great. Okay. Similarly, here there are a few more things like geoneer. Okay. In geoneer, basically, when you have a lot of data, all right. For this, I don't have a data right now. Okay. I'll have to find out the actual data. Okay, so I'll try to explain it without a practical example. So these were all very, except for the unwind, everything else was so far the traditional way. And MongoDB comes up with geospatial operations, meaning you can find out something based on the location. Let's say in your traditional database, you have 3 columns: person name, the x coordinate and the y coordinate, or latitude or longitude, latitude and longitude. You have these 3 columns in a table. Now, given a particular point on the earth, how would you find out which are the people living in a 1 kilometer radius from that point? Okay. So, how do you do it in case of traditional SQL? Anybody? So you have got a table which contains latitude and longitude, lat long, of each person which is living on Earth. Okay, or say in particular cities. Okay. So how do you? My question to you is, how would you do that in a traditional database? You have to find out people living near to 1 kilometer in the radius from a particular point. How would you find it using traditional database? Anybody? Okay. So that's what it is. So basically, none of the traditional databases have been providing us these kind of functionality. But in newer days, it has become very, I mean, demanding to have such kind of need. Okay. Basically, when we deal with big data comes in various formats, starting with text, and binary to your traditional transactional data. And therefore, since MongoDB is supposed to handle both kind of data, whether a big data or a small data, MongoDB provides you these operations which are not there in the traditional database. To build such a service itself requires enormous amount of capability, and I mean, to make it really efficient is extremely difficult. Therefore, MongoDB guys did it really nice. So I was building a Twitter like service. I mean, basically one of my friend was building. It was a location based Twitter. All right. So we had to find out all the people living near particular point, and provided all these people have given their locations. Now it was extremely difficult to do the computation, because because how do you do it? You cannot compare on X, you cannot compare on X and Y together. You will have to either go with each and every, you have to either you compute the distance with each and every points, and then you compare their distances, then you find out, order the distances, and then list down that this person is this much away. So it was very, very difficult to solve this kind of problem. Therefore therefore what we came up with something like a zip code architecture. Okay, we created these zip codes of the whole earth, of say 10 by 10, 10 kilometer by 10 kilometer radius, and we gave it a zip code number, and put people into those zip code number based on their location. So once we have indexed all the people in a rectangular format, created all these squares uh, on the earth, and giving every square a name and putting people into each square, and every time somebody says, give me a 5 kilometer radius people, we just find out which square does it lie in, and then we find out all the squares surrounding that square also, and then we compare only with those people. Okay, so that was one strategy, and it required enormous amount of effort. So to solve those kind of problems, MongoDB you gave you a handy functions and aggregations, such as geoneer. Geoneer says find out all the people who are living near this coordinate, and they should be maximum of 8.008 units away from it, and default dimension is kilometers here. Okay, and here the geoneer also gives you one more parameter, like a filter command, okay, called type colon public. Okay, which it will apply on the data. Like here you have type colon public, and it applies on it, and coordinates of all the documents are specified in these kind of formats. Also it looks for a field called dist.calculated. Like here you can see in the output, you see there is a field called dist.calculated, and that's it. So this is one example, one very, very simple example of geospatial queries. All right. Does it make sense to you guys? And it says num column 5. Give me 5 results. Okay. So let's just look at first this operator called geoneer. Okay. Geoneer says find me find me all the people living near this coordinate, and near this coordinate at a maximum distance of this much. Okay, and distance field which this guy has to take into consideration is the distance dot location. Okay, so it will find all the people living. And how does it find the location of people? It is in the field called location. Okay, dist.location. All right, this is where the location is. So basically it is very simple way of saying, if we drop a pin on a globe and you have to find out people living in 1 kilometer of radius, this is probably the most efficient way as provided by MongoDB. Okay. In places collection, it is as is. These are the places collection. If you see each, this is one document. Okay, this is one document. You can see the document because we are not manipulating any other field. So document will be presented as is. Okay, so this is the document, sample document. It has got an ID, it has got a name, it has got type, it has got a location. Okay, these are the various locations also. And then it has got, when we say location, right here, location, it is basically a rectangular coordinate. Okay, or you can think of it as a polygon. Okay, and then it does the other stuff. So you just, for time being, just think of geoneer as your way to find out all the points or do a geographical intersection on a large graph. Okay. Okay, never mind. We will look into again these things again with proper examples. Right now, I don't have a running example for this, but I can show you the. I'll show you the more examples later point of time. Okay, once I have this thing prepared. But right now, I just understand that it is possible to do a geoneer using our standard aggregation pipeline, and then you can apply further aggregation on top of this output. All right, don't worry. I mean, it's not a very difficult thing. It's just a syntax thing. And since there is no there is no relation in the traditional database, that is why we are also finding it difficult. Now there is one more operator, or one more function you can say, called redact. Redact is specifically good for trimming your document, and in particular for trimming the documents which are trimming the children or the parent. Okay, now let's have a look at this. We have got a accounts collection. We have inserted this document. Okay, we have inserted this document, and in first pass we did a match. We matched the documents which has status colon A, meaning this one is going to get selected. All right, then second thing we did was we did redact, and redact has this format called, first operator is, it has a condition. Okay, in this condition you say that in the format of if then else, if the label is 5, okay, then prune, else descend. So the moment it encountered at anywhere label equals 5, anywhere, okay, it will prune that one. Okay, which means CC will go away, this will go away. Okay, and the moment it hits the second one here, so CC, okay, CC basically label 5 is there here. So CC is what this whole thing is, and this will go away. Okay, if we say label equals 3, if we say label equals 3, then and then say prune. Okay, then in those cases only shipping address will go away, only this portion will be pruned. Okay, only this portion will be pruned. Let's have a look at it. All right, db.accounts.find, and we can say pretty. All right, so this is what it is, and we can say that db.accounts.aggregate. So the output we get, it has only those things left. Now let's say we go for label equals 3. So shipping address has gone away, as you can see, right? Shipping address has become empty. Okay, similarly, if you just want to delete this particular field, we can or this particular document which has got city equals to city 3, we can say we can say here we can say city equals city 3. So that particular node has gone away. If you see, let me just do a pretty. I'm not sure if pretty works here. Okay, good. It works. It works after the aggregation also. Okay, so our city 3 has gone away. This city 3 has gone away. Okay, so this is specifically for trimming a document, removing its children, or removing a parent. No, none of these is actually performing any physical deletion. It is basically transforming and giving it. It is up to you whether you want to persist it or you want to update the old one also. Okay, it is completely up to you. Make sense? Can you show example for else in redact? Okay, you mean to say that I mean, let's say that we want to do one thing, that whenever we hit a label equals 1, okay, we want to descend. We want to descend. And in case we hit else other, we delete. Okay. What happened now? Again, this thing actually bothers me. Okay. So only the label 1, when we say label equals 1, then descend, otherwise just delete it. Okay. Okay, let's see. So it says that okay, let's say that, how should I show you? Okay, let's say we both the places we say descend. Okay, we put a comma here. Again, this guy doesn't keeps on changing my double quotes. Okay, so for time being, what I did was I did nothing. I kept on saying keep on descending, don't move. In that case, it just kept on descending and didn't do anything. Okay, all right. What we can do is we can have another document without any label. Okay, and then we try this one. Okay, you can try that when you are free. Okay, these all documents will be made available to you anyway, so you should try that one. Okay, all right. Yeah, it has only two keywords like descend and prune. There are some more. Yeah, you can have a look at those things also. Okay, so this is pretty much I mean what we call basically aggregations. Now we will discuss more about it. Okay, we'll discuss more about it in the second session, and we will have further discussions on around this. I mean, after the break. Okay, do you guys want a break? 10 minutes. Okay, so just let's have a 10 minutes break and come back quickly. Okay. Okay, let's take a Okay, so I'm hoping that everybody is back now. So as Anul's question is that since we don't have a temporary table concept, we have no option but to create a permanent table. And what are the adverse effect of that? Okay, so basically, there is already a request pending with MongoDB team for creation of a temporary database. Okay, very low. Just a second. Let me see. Hello, hello, hello. Is it very low still? Okay, okay. Is my voice not clear to other people? Okay, okay, okay. Now you can hear. Great. So let me go back to his question. Anush was saying that since it doesn't have a temporary table concept, what are the adverse effect of having a persistent table? There are definitely an adverse effects of having a persistent table, and there are actually many such incidents. So one of the ideas is to have a timestamp based collection in which you dump your temporary data if required. Okay, you quickly create a timestamp based collection and then you dump the data into that. Okay, the only downside is that if the two basically two processes are trying to do the same thing at the same time, then there are chances that the data will mingle between one user and another. Okay, so there are high chances. And because of the same reason, people have asked MongoDB. Probably they will be working on it, and I don't know what is their stand. I saw that there is a request logged in with their team. Okay, but I mean, even in the absence of that one, we can live with the timestamp based collection. So in the name of the collection itself, if we create a timestamp base, that will be sufficient. Okay, now and half of the job of say why did we create temporary tables in first place? Temporary tables was created with an objective of having a temporary tables was created with an objective of because select queries need to either we keep on joining complicated joins or the data pipeline issue actually solves a lot of temporary table problems. Okay, but yes, it's still required even if there is a data pipeline. I believe that the temporary table should be there per session based, and hence it should be they should build a feature on it. I think that they must be working on that. Now, so there are some more properties of GeoNear kind of uh, project aggregation, because GeoNear is there are some restrictions on it. First one is the biggest restriction is that it can be the first stage of a pipeline. It cannot come later in the pipeline. Okay, why? Because because it cannot search in the documents on the fly. Okay, any documents which it needs to search should have an index created on it. This is one such projection aggregation. This is one such aggregation which does not work without the creation of the index. As I told you, the way we were creating the zip code, right? The way we were creating zip code, in the same fashion, these guys, I mean, in the same fashion, they also create some sort of index inside. I will in one of the sessions, I will go into the details of how exactly they are marking the reasons. Basically, they are more or less dividing the um, whole rectangle into four pieces, and then each of these four pieces they divide it further and keep on giving each section a name. Okay, and thereby giving so thereby indexing becomes essential need. And when the pipeline is going from left to right, the indexes are not created uh, uh, on the fly. Therefore this kind of geoneer doesn't work on the documents input in the pipeline. So therefore, it makes sense to have have geoneer as the first 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 uh, first operation in the pipeline. Okay. Then in the output field, you need to have distant field option. Okay, distance field option as in, okay, distance field option meaning that when it tries to find the points which are closest to it, it uses the distance field also. Okay, and therefore you need to specify a field called distance field so that it can store the temporary values onto the distance field and will compute and put the distances of those points from your points where you're looking from. Okay, and in the output you can sort by the distance, you can sort by other features, it will be up to you. Okay, now the third point is collection must have geospatial index, which is anyway I've covered. And there could be at most, so this point I'm leaving right now because right now I've not described you what is the indexes and geospatial indexes. Okay, so there are two kinds of geospatial indexes. One is 2D index, one is 2D sphere. So at most one 2D index and or one 2D sphere index, okay, should be there. So basically there is a hard requirement on indexing, and while indexing you will have to specify that y- your location is stored in this field in this document. All right, so basically when you say geoneer, it basically means that it will use the index which you have already defined on this table on a particular column, and it is just looking for the nearby that location. Okay, and the strategy in which it is going to search is based on this index. So this is more or less about our index. So here I'm going to take a step forward and you also should download this. Okay, so I'm going to download a JSON file. Okay, here, actually, whenever you're working on the servers, right, you should create your own folder. Okay, here, so I use wget for the downloading of any database, any URL, and this database contains 3 MB of data of all the states of United States. Okay, I think it's not states, it is the park, I think. So let me see. So for Mongo import, I can say Mongo this, okay, and I say Mongo import, okay. So any JSON file which is well formatted, you can import it in this fashion. All right, you can import it in this fashion. So I'm importing gyps.json, which is a JSON file, basically a collection of all the documents, into a database called asgiri, into a collection called cities, and I'm specifying username and password. Okay, let me see if I can. So what does it want? It says authentication failed. And let's see, what does it want? Authentication database. This is okay. This is okay. Minus U minus P, that is okay, right? So let's say Mongo import, and we'll just try to do this. Okay. And then I say, I'm just changing the order. So I'm trying to import the data. I'm trying to import the data to my database using. Why is it so? This works, right? This works. Oh, I think it is the problem with the database name. So let's just put the database as test. Right. So it is importing the documents now. It has imported the documents. Now we say, all right. Now we say show tables, and we have cities, right? db.cities.find1. So in this, you can see there is an ID, there is a city name, then there is a location, okay, location in this coordinate system, and then there is a population, and then the name of the state. So these are all the cities of United States. And on this, we are going to do some more lookups. All right, let's do some more lookups. This is the format of, okay. So let's say that you have to return all the states with the population greater than 10 million. Anyone? If you have to return all the states with a population greater than 10 million, what will you do? Okay. Anybody? Any quick way? Okay, match phase, good. So return all the states. Okay, remember this population, you see POP, it is the population of this city. All right. So first you have to compute the compute the population of the city, population of each state. Yes. So first sum all the state, then match. Okay. So all we have to do is, it's a combination of group and match. Perfect. Perfect. You guys got it correct. Okay. And can anybody write a proper format right now? No. This is what we are looking for. Can anyone? So basically, if you look at this problem, here we are trying to say that find all the state with a population greater than 10 million. Before doing a match, we will have to find out the population by summing up the population of all the cities in a state. Okay. So for doing that, you need to group by the state and then sum the population. And once you are done with that, you apply that we want the only this population. Okay. Now, if we say that population greater than 10, top three maximum populated cities lesser than 10 million. If you have to do that kind of thing, what will be your approach? So let's try to do this first. Okay. Okay. So basically all we did was first did group by. We said group by ID called state and create a column called total, which is basically sum of all the population for a state. Okay. So basically as a result of this, let's say we are not applying a match phase here. Okay. We are not applying a match phase here. Okay. So you get a lot of states. Okay. And if we have to just find out top three most populated one, we have to do is first order by say total, order by total 1, and that's it. What was the sort or order? I think it was. No, I think, yeah, this is the way it is. Okay. So it is called, I think, sort. Okay. And if we want to say descending, we just say this. So we have got California as most populated city. And if we just want to display, uh, we just want to say the top three. Okay. And so we say limit 1. So limit 3. Okay. So group followed by sort followed by limit. Okay. So this is one way to solve these problems. All right. Excellent. So let's just also try to do this. Basically, all we have done is that's it. So we did a group here. See the group. Found out the state population. Then what we did was we found out this. Okay. We said After all the computation, we said match the total greater than 10 million. Okay, is it 10 million, right? Yeah, it's 10 million. 4, 5, yeah, 10 million. Okay, sounds good, all of you? Should I repeat in case anybody is left out and some of it, I mean, I can repeat, I have no problem at all. Okay, anyone? Was I able to explain properly this part? Good, good. So similarly, you can do lots of transformation, lot of query using these techniques. Okay, using these techniques, we can do a lot of querying, and most of the assignment will be based on this document, this only. So uh, you will have to download this and get familiar with it. All right. So these were the basic querying in case of MongoDB. Okay, and uh, things to be noted is that it provides you all sorts of aggregation phenomena. There are things like text search and all. We will discuss those things while discussing the indexing. Okay, we'll discuss the text search in when discussing the indexing, and we'll take a bigger example for indexing. And the next one we are going to talk about today is uh, the programming model. Okay, called MapReduce. So how many of you are basically aware of what is MapReduce? Except for Umang, of course. Okay, okay, okay. So nobody seems to know what is MapReduce. So so far, I mean, other things which I forgot to tell you about aggregation is that it is fairly scalable model. Okay, the way MongoDB has implemented it is that even if there are thousands of machines running MongoDB in parallel, there are thousands of shards running MongoDB in parallel, still aggregation is just perfect way of querying. Okay, the aggregation will return you the right results in a fairly small time. Okay, so aggregation is fine, but sometimes you will have to do a lot more than aggregation. Say, for example, you have to um, you have to say character by character analysis of a text file. Okay, or there are whenever there is a programming requirement, your standard aggregation do not seem to suffice. In those circumstances, you might have to run some code across the network. Okay, you might have to run some code to produce the result. So MapReduce is basically a programming paradigm which makes it possible to do the computation on thousands of machines parallelly without you bothering about the details of synchronization. Okay, so you write your map and reduce functions and then hand it over to the system which executes them systematically and gives you the result. Okay, I will go into the details now. Basically there are examples where your standard aggregation would require too much of work, meaning there are examples in case of SQL where you don't have to where your standard SQL does not suffice. That's where PL/SQL comes into play, or you have to write for loops and other things. Okay, so similarly, in case of MongoDB, you can actually use JavaScript from the command line, but that will only be executed on that client only. It will not be executed on multiple servers parallelly. If you write on Mongo command line any JavaScript, it is going to get executed on only on that machine. Okay, not parallelly on all machines. So to do a proper querying or proper parallel execution, you can write your code in MapReduce terms. So let's take a case. So uh, MapReduce is basically you will be writing a function called map and a function called reduce. Okay, so let's take a case of that you got two documents. You got two documents, and each of these documents contain name. Let's just imagine for time being, in these documents there's a field called name or field called song, which has nothing but space separated words, and we want to do a frequency analysis of these words. And what do I mean by frequency analysis? All I want to do is sum up, find out the frequency of all the words in the name. Okay, name is like a name has a big sentence. A name has a big sentence, and there are so many documents of this type. You can think of hundreds of millions of documents or tens of billions of documents lying there. Now you have to do an analysis of, say, you have to count all the words in the field called name. Okay, how would you do in standard fashion? If I have to ask you, say there is no such function in case of aggregation which can help you straight away. Now how do you do this? Okay, so in those cases you write your map function which will convert this document into further documents which will get aggregated by the reducer. Okay, so now let's have a look how does it work. So the duty of a your map function is to produce key and the value. Okay, key and the value. So it took this document called sarega and converted into key and value. Here value is constant called 1 basically, and key is each of the name. Okay, each of the word in the whole sentence. Okay, now system will sort it for you and then feed it to your reduce function after combining all the results. Okay, let me first show you an example first. Okay, so mm actually a map function example will be a better idea. Okay, okay, inside I don't have a good. Okay, so let's say my function is there map. Okay, and it has got something. So we say, so I define a function first of all, saying this is my function. Okay, and here I say emit in this whatever document is there, this dot name dot split by space, and all I do is for okay for I equals 0, let me okay, now for I equals 0, I less than array dot length, and then I plus plus, And let me do is first let's just print array I and okay, perfect. So this is my map function. Okay, and okay, okay, and instead of saying here print, I say emit arr comma 1. Perfect. Now I write something called reduce and say function, and in this one what I do is, sorry, basically you'll have to write reduce and function, and here you will get key and values. All you do is return array dot sum and vals. Okay, now we have got two functions. Now let's create a basically a database called songs, and in this I'm just going to insert name. I'm basically trying to emulate whatever it is here. All right, this and okay, perfect. Okay, now similarly this portion. Okay, now if you see that we have just created the sample for this example, we have got two documents, one is this, other is this. We have created a map function. Basically all it does is it splits this string by space and then run it. Okay, so if you see, if I have a space b and say split here like this, so it creates an array for me. All right, now I've got a function called map and I've got a function called reduce. Okay, so if you see, look at what map is doing. It is taking the field called name, splitting it by space, and whatever array comes out, it is iterating over that array, and it is emitting each value and 1. Okay, similarly all reduce is doing is summing it up. Okay, oh, I have wrongly, never mind, I'll just, thank you. All right, perfect. Now getting back here, so here your map did this thing. Now imagine that you have hundreds of such shards. Okay, each shard containing thousands of documents. Now your map function is going to be sent to multiple machines in parallel where your documents are lying in the network, and and map function is going to be applied on all those documents. Okay, on all those documents, and then whatever is the result of your map is going to be sorted and then merged with the result of all other maps across the network. Okay, all all the results, like here if you see the second stage, here the data got sorted on all different computers, and what kind of data is there on each stage is displayed very well here. Okay, so this is my input in case of first shard. This is my input in case of second shard. This is my this is my output here. The second stage, the map produced me this output. It's the same function. All it did was split it this. Okay. Similarly here, and in the stage 3, they both got sorted individually, and in the stage 4 they got merged and then splitted. Okay, they got merged here like this. And once here, just after merging and resplitting, why it was done, so that the reduce function can can be done parallelly. All right. Now, why the sorting was done at this stage? Because sorting individual sets and then sorting individual sets and then merging them together is easier. So when you have to sort a huge data, when you have to sort say 10 terabyte of data, it is not possible to do it on a single machine. It is better to do it on multiple machines together, and that is what is being done here. Okay, you can imagine that map all map did was produce the key value pairs, and then that the whole data got sorted. MongoDB sorted that whole data based on the key and then grouped by key, and whatever the array came out because of grouping on the key, that was fed to your reduce function. Okay, that was fed to your reduce function. Okay, and now reduce function, all reduce function did was combined all the results together and gave out the output. In 4, okay, in 4, how ga re came out on the left and sa on the right. Perfect point. So here at this stage, so if you, let's take the output here. Okay, so this was given out by who? By sorting of the individual machine. MongoDB sorted the collection on one machine. Okay, why can't I copy this? Okay, so this is from the one machine and this is from the second machine. You agree with this till this point? Okay, first machine gave me this and second machine gave me this. Okay, now imagine you have to merge this result. You have to merge this result, so it will be easier if they are sorted. So they are sorted, so you pick up the first one from here and put it in the output. Now this goes in the output, so it keeps on reading from both the sides and based on which one is smaller. Now all of these, since they will be merged together like this. Okay, like this. So had it not been sorted, it could have been a nightmare to basically merge them together. So in this phase, if you see merge, basically it's a two-phase statement. It's called merge and split. Okay, so some of the keys go to one machine while some of the keys go to another machine. And that is what has happened. So it divided into two sections like this and this by itself and then reduced it and gave the output. Okay, and it made sure that all the keys belonging to one particular uh, all the keys are basically on the same machine. So there is a data transfer going to happen. Yeah, splitting sequence is decided on the fly. Yes. So basically on what keys, which keys are going to go to which reduce and which keys are going to go to which reduce is all decided by MongoDB. And by default, there is only one reduce function. Okay, there is a single instance of reduce function, which means this splitting doesn't happen by default. Okay. So basically the other way to look at MapReduce is map is your when you think about your group by clause. Okay, group by has got two features. In case of, okay, let me see Rizwan's question. So merge happen on which shard or independently? So merge happened on whatever shard is available. Out of, say there are 100 shards. Okay. So out of these shards, it will be decided the one which is going to have the maximum number of keys or maximum number of data. So so you can imagine that the each of the sorting resulted in lot of documents. Each of the maps resulted in lots of documents, and therefore the sorting need to be done. And after the sorting has happened, this both the results have to be merged together to produce some output. Okay, so which question are we doing? Let me just complete this. So uh, and the merging can happen either on the shard 1 or shard 2. Okay, half of the data from shard 1 goes to the shard 2 or vice versa, not on the third machine. So either of these shard is chosen to little bit reduce the data transfer. So here there are a couple of very important things happened. First, the code went to the data didn't come to the code. Our mapper was replicated. Our map function was copied to all the machine and executed on all the machines where the data was lying. So you had a huge collection. Some of the documents were lying on the shard 1, some of the documents were lying on the shard 2, and some of the documents were lying on the shard 3, and so on. So your huge collection containing billions of documents was spread across hundreds of nodes. Okay, in this case, if there is a single client who is querying all of these and iterating over the documents one by one, it would become a nightmare. That single machine will not be able to finish the computation, and therefore it makes a lot of sense to send the code to the node rather than bringing the data to the code. Okay, so it makes a lot of sense to send the code to the data rather than bringing data to a particular node from all the nodes which contain the data. Okay, therefore map is sent to across the network, and map is applied on each document one by one. And once that happens, whatever results that map gives out is aggregated. First is sorted on each machine and then aggregated together to produce again another set of, you can think like a set of another set of collection which is sorted based on the map key. Okay, and all the values have been aggregated together, grouped together. Now reduce function is now applied on top of this collection so that you can sum up, average, minify, and all sorts of things you can do using reduce function. Okay, ideally anything you do with map and reduce is basically, it's a two phase selection of an id and then grouping based on that id. It's like group by clause of SQL. In group bys you say s- select star from my table, select id column comma sum of the salary. So this is how your standard SQL looks like. Select star from table T, right? Now say you are doing group by, and this table has got say two columns, ID and salary. Okay, So we say sum of salary group by ID, and that's it. Okay. So in this case, who is doing the job of a map? The job of a mapper is being done by group by. Group by is doing two things. First is selecting the ID, okay, and then for each ID, whatever values have come up, execute all those values uh, with a aggregation function called sum. So similarly, this is our reduce function, and group by is our map function. Okay. So okay, let me see. So which question can you copy paste, Vahid? Yeah. So I was explaining it here. Basically, here in this phase, when it's merge and sort is happening, it is re-splitted after both the output from both the legs, both three legs marked as 3. Okay. It has come together, then it does the merge automatically. Yes, yes. Yes, Kishore is right. Basically, it why did it reshuffle? So that why did it do what is shown in the step 4 here? Why did if you see, the ray from the right went to the left, while sa from the left went to the right. Okay, the objective is to group all the values together. This is basically a huge group by clause. Okay, does it make sense? No? Should I try to explain again with more examples? Yes, for which one? More examples? Excuse me, I might have to take up this call. Just hello. Okay, okay. So merge is basically, I mean, instead of somebody sorting on a single machine, it sorted the data on each shard 1, shard 2, and then merged it. So merging, so instead of, the idea is that instead of sorting on a single machine, the trick is to let each machine sort the data, give you the sorted data. Okay, once each machine has sorted the data for you, merging that data is far, far easier. Okay, merging that data, you can imagine that there are two rows of people. Okay, there are two rows of the people standing in an increasing order of height. Okay, Just a second, I will inform some people. They are trying to knock on the door. I'm extremely sorry. Hello. Hi. So basically, some people from auditing are coming. So that is why, and they come on the random timings. They have not informed at all. Okay, never mind. So basically, we saw. I mean, you imagine that there are two rows in which people are standing. Okay, and in the increasing order of their heights. Now, if you have to convert that row into a single line, into single row in the increasing height, it will be pretty easy, right? If there are two rows in which there are people standing in the increasing order of their height, and you have to merge them together so that the shortest one is in front, the order and the tallest one is the back, in the same order in which they were standing in the two rows, it will be far easier to do that. Okay, therefore the data was sorted on each of the shard 1, shard 2, and once merging happened, it quickly splitted half of the queue, half of the row from the middle onto two machines. Okay, so that it's easier to basically go along with the with the basically uh, same IDs will go onto the same machine rather than different machines, and hence your reduce function can be applied. All right, did it clear anything? Okay, okay, yes. So I'm on the phone. Okay, yes. So let me try to explain you one more time. Okay, so if we use nearest, then only those shards will participate in map and reduce. If we use nearest, then only those shards will participate in map and reduce. No, no, no. Wherever our collection is lying in the network, if there are hundred such shards, then my containing my collection, collection, whenever you add a lot of documents into a collection, then that data gets spread across the hundreds of computers, and and then you can basically all of those computers containing your collection will be participating in this whole process of map and reduce. Okay, okay, so let me just go step by step again in this. So there were two computers, shard 1, shard 2. First one containing a collection, second one containing a collection. Your map were applied on both the sides, and then whatever came out of a map was then sorted and merged, and then reduce was applied on it. And for time being, let's just assume there is a single reduce function, then also it will make equal sense. Okay, so reduce was applied on each key. Whatever key was produced by map, it was done by this. Okay, so it's like a grand group by function for you. Okay, ideally say you have to do this, and say that sa re ga ga is basically a word. All you could do is group by that word and then say sum on that number. Yes. So after merge, gar array go to reduce of the shard 1 to n, rest go to shard. Yeah, this is just an example. It might be very, very different. Okay. It is completely arbitrary based on the load at that time, which machines will be participating and which not. Right now, for the simplicity, you can imagine that there is a single reduce. Okay. There's a single reduce and output is just getting merged and sent to a single reduce function. Okay. Let's just imagine that the output here is basically merged together and it is being done on single machine in the reduce function. It's the same thing. Okay. Any other questions? So on the same line, now I have defined a function called map. Okay. And I have defined a function called reduce. Okay. And I have got a db dot songs dot find. Okay, now I can apply map reduce on this one, in the same fashion like this. Okay, I say map and red and that's it. Okay, and okay, okay, so here, and I'll have to map reduce, and then I'll have to put options here, and in these options I'll have to basically put out and say my file. Okay, so this was done and we will have my file dot find. Let's see what happened. Okay, so you see that it has done the job. Okay, it has done the job. Okay, single shot. Now let's take another case. Okay, before we get confused further, let me just take one more case. So, Rizwan, is there any algo that decides how much data go to which shard in case of multiple shards? So basically, the general algo is it needs to minimize the data transfer. Okay, it needs to minimize the data transfer from one point to another. Okay, and uh, therefore, it is basically maybe MongoDB is doing something over there, and I'm not really sure what algo do they use. Okay. So it happens internally. All your only duty is to write a function called map. The way I wrote here, I wrote a function called map. I wrote a function called reduce. Reduce only does is sum it up, whatever values are given to it. Okay. And map only does is splits the name by space and emits it line by line. After sorting the result, come to the same for both the shard. So, so we can have a can you want some water? Okay. After sorting the results come is after the sorting the result comes is same for both the shards. So can we take only one reduce? No, because sorting the results will be different, of course, because the data is going to be different on both the sides, here as well as here. So the data is different. So after the sorting, and the result will be different in both the shards, right? Kishore, let me take one more example. Okay, if let me take one more example. So let's take a case of a customer. There are three customers. One this ID, other this ID, other this ID. Now we say we want to do that. We want to compute. the compute per customer charges, per customer costs. Okay, we have to say compute per customer cost. So basically this and this need to be summed up. Ideally you would just group by, right? You'll just group by. Okay, but here I am just taking extension that whatever you were doing with the group by, you can do the same thing with the map and reduce. So in your map, what you did was emitted the customer ID and the price. Okay, customer ID and the price, which is ABC12325, ABC12434, ABC12435, based on this data. And then once all MongoDB did was it grouped together the values. This key, and it has only single value, so there is single value in array. And MongoDB did was took another key and aggregate it together. And your reduce function, which just sums up the array, summed it up. Okay, make sense for you? No? So basically everything happens between map and reduce is basically the duty of MongoDB. MongoDB takes your map function, applies to the documents in a collection, and then whatever output comes it gives to the reduce function. Okay, and if you look at it, if you're doing it on a single machine, it will be very simple example. It is like it took the document, gave it to map, whatever output came it sorted it, and then send it to the reducer. That's all. Okay, but if it is happening in the network, the sorting happens over the network. Okay, so let me just show you this example very quickly. So we have got first customer, we have got second customer, and we have got third customer. So we say db.cust.find. We have got all these three records over there. Now in the first shot, our map function is this one, which all it does is this object. If you see this is referring to the document itself, and cust id is the field of the document. Okay, similarly price also. So we just defined our map function. All right, similarly we have got reduce function. Reduce function is given two things: key and array of values. And you can do whatever you want to do with the array of values. You can, instead of summing up, you can do average, you can do square root, and anything you want to do. Okay, because it's a full blown programming language which provides you all kind of functionality, average, standard deviation, and whatnot. Okay, so if you are comfortable with the programming language, you will find uh, uh, a JavaScript far easier to code than writing a group by function. Now I defined my map function, I defined my reduce function, now I am executing it, and that's it, done. So there is an out is one parameter which says that you can store the output there. Okay, so it did was it summed up for ABC1 to 4. Okay, anything else? Yeah, any more questions? Okay, what does emit does? Emit is what gives out your key and value pair to the system. It here, this, when I said this is the job of emit. Okay, it tells MongoDB that this is my key, this is my value, this is my key, this is my value. Okay, and MongoDB takes all those key value pairs, aggregates them by key, and hand it over to the reducer. And reducer is your function which combines that together and joins it. Yes, cust2 ID is the key and price is the value. Perfect. Okay, any other questions at this point? Try to think about it. Basically, map is a great way of defining your ID and the value, and for grouping to happen. Okay, and grouping is done by the MongoDB for you, and whatever values came up as an array for each ID, you can convert that array into a value using your reduce function. Yeah, map readout is a collection, and it the whatever is the output of the whole thing, it is stored in that map readout function. Okay. Okay. Yes, it exists after the session. This is your gateway to your results. So there are a lot of complicated things. There are a lot of full blown, say you are doing a statistical analysis of a large data, or writing a machine learning kind of algorithm on top of lot of data. In those cases, JavaScript will come out pretty handy for you. Okay, because not everything can be done using aggregations and SQL, and therefore it makes a lot of sense to be able to do the querying on multiple systems parallelly using your programming language. Okay, and MapReduce is one such paradigm which is popular across MongoDB, Cassandra, Mahout, Hadoop, and Apache Spark. Everybody has started using MapReduce. MapReduce was a paper published by Google in 2008, 2007 or 8, by a person called Sanjay Gehmawat and a person called Jeff Dean. So they said that this is how we do a computation at Google when we have 10,000 of computers aligned in a network. And all they did was, all you have to do is just define your map function and reduce function. Rest of the job will be done by the system for you. So it's a grand way of doing grouping in a map reduce way. Okay, a lot of things, if you think about it, every select query is nothing but a problem of map reduce. Okay, when you say select this or that, you are basically saying this is my ID, this is the values. Group by is the same thing, ordering is the same thing, and so on. Okay, if you have ordered something, you all you have to do is spit out those values as key, okay, in that fashion in which you want it, and then it will be ordered accordingly. Okay, so almost all the SQL related problem can be converted into a map reduce paradigm. Okay, almost every SQL kind of a problem can be converted into map reduce, but a map reduce can do a lot more than that. Okay, so any other questions as of now? Feel free to ask me this one, and I'll try to explain it maybe in the next session again if you are not clear. Okay, so okay, so okay, 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 okay. So does anybody have any questions related to MapReduce aggregations? So we will be giving a assignment on MapReduce and aggregations. Okay, in case anybody is having questions. Okay, okay, okay. Somebody is saying, great. So on this screen, you can see that I'm doing a Mongo import right here. Okay, so I said Mongo import minus minus file, and then I said this. Then basically I specify my file name, then aggregation name, database name. Here, make sure you type for some reason it was not working for my database, so try with the test. Okay, try with test. Okay, try with test. So it should work. In case you are doing it on local machine, try on test, or it has been imported anyway for you. Okay, so it says that this file need to be imported into this database and these cities. Okay, so this is relative to the location, present working directory. This is relative to your present working directory. Okay, you can either specify the full path or relative path from your current directory from which you started the Mongo import. Okay, and just download the file from here. Best way to download is you do wget, and then that's it on a Unix machine. All right. Any other questions right now? Yes, it is already downloaded on the server and also imported. Okay, I'll be sending you the list of assignments. I mean, the list of assignment will appear on the server by today night. Okay, and you start working on that. So MapReduce is basically how which ID to select and which one to use. And you can combine MapReduce and aggregation together to get the desired results. Also, since you are storing the data in the collection, you can further again reapply MapReduce on the collection and put it on the another collection. And you can keep on doing it until you get the desired result. Okay, you can combine map and reduce and aggregation together. So the way people do it in industry is they start with a simple aggregation. Wherever they get stuck and MongoDB standard aggregations are not helping, they devise their map reduce function and then they get it done. Okay, so that's pretty much for today. I have actually some more things to do. Some people are waiting, so I'm extremely sorry to stop the session today. Okay, but we are pretty much through with our sessions, our topics for today. Okay, and that's pretty much for now. Okay, feel free to drop me an email in case you are not clear about MapReduce. I would love to explain it again in more details. Okay, so but I need to understand exactly. I mean, who all did not understand it? Just drop me an email. I'll try to respond to your emails as much as I can, as quick as possible. Okay, okay, great. So I'll be giving the assignment soon by today evening, and then you can start working on those things. Okay, thank you, Umang. So great then. Okay, so feel free to connect in case there is a doubt, and if you want more detail, Sanjeev, in case of any doubt, just let me know. I will discuss further. Okay, and we'll try to explain more. Okay, thank you. I have to just disconnect right away. Bye bye.